So in the previous two sections or PowerPoint lessons, we've learned about the normal distributions and then how we can do normal calculations using the standard normal curve. But those calculations are only appropriate if a data set is at least reasonably normal. So there's some ways that we can assess normality, and that's what we're going to talk about today. So this is what I had just mentioned. A lot of times we can use calculations like we just learned with real world data, but it only works if the population is approximately normally distributed. And so that's something that you'll get into as you start to do these inference procedures, is that one of the conditions is going to be the population's approximately normal. And that's something that you always have to justify. You have to say, I'm going to assume that the population is approximately normal. Or you have to say, I've done this to check that it's reasonable to assume that the population is normal. So one way we can do that is by plotting the data. So you can make a dot plot or a histogram or a stem plot. You do want to be careful with box plots. So box plots are a good way to check for outliers relatively quickly, and they can even show us skewness, but normality can't be seen. You might be able to see symmetry in a box plot if you have something where the right and left-hand sides are approximately the same. But that doesn't imply that it's normal, because maybe this is something that's bimodal but symmetric. So it's symmetric, it has a symmetric box plot, but this is not giving us a normal distribution when we graph it with, say, a histogram. You can also check to see whether or not the data follows the empirical rule. So essentially, to do that, you're just going to count how many observations fall within 1, 2, and 3 standard deviations of the mean. So you will run one variable stats if you have the data, and then do the mean plus or minus 1 standard deviation to come up with a window. The mean plus or minus 2 standard deviations, come up with a window. And then the same 3 standard deviations and come up with a window. See how many or what percent of your observations fall within each of those. If it's reasonably close to 68, 95, and 99.7 respectively, then we're going to say that it's reasonably normal. And really, you wouldn't have to do both of these. And there's actually a third way we're going to see in just a minute. You would do whatever is appropriate for what you're given, which usually you'll be plotting the data. You do have a homework problem tonight that's going to ask you to check that empirical rule just so you can see how it works. So the third way that we can assess normality is by using a normal probability plot. And so this is not something that you would do by hand. It's as most software packages. So you would use a computer or you would use a calculator, which I'll show you the screenshot of that in just a minute. But what it does is it plots each observation against its corresponding z-score. So you'll have z-score on the y-axis and then the original x values on X. And so really, you'll use some sort of technology to make one of these, and then you just have to use it to assess normality. So if the points on a normal probability plot, or NPP for short, are slightly linear, or they lie close to a straight line, that tells us that the data is approximately normal. If you see any sort of a curve, or if you see outliers, that would be indications of non-normality. We do want to be careful when we're talking about the data are normal. We always want to use those LY words. So when we're saying something's normal, it's approximately normal or roughly normal. And when we use a normal probability plot, we really want to be specific. We're not going to say linear, so normal. We're going to say the normal probability plot is roughly linear, so that indicates the original data is approximately normal. You need to say what you see and what it indicates. So here's an example. You have a histogram. If we had this histogram, we wouldn't even have to go any further. This is skewed to the right. So that tells us we can't use Z and standard normal distribution. We can't use the empirical rule, none of those things, because this histogram is not approximately normal. But just so you can see how that looks in a normal probability plot, you've got your z-score on your y-axis, the original x values on x, and then you see that curve or that kind of leveling off on the right-hand side, which shows us that we have that right skewed distribution. So this also, if we only had the normal probability plot, would indicate the right skew and that we can't use z-scores or standard normal distribution. So like I said, you can make one of these on your graphing calculator. All you would do is that you'd have the data in a list, and then you go to the stat plot menu, which again is the second button, and then y equals, that same place that we make histograms and box plots. All of our graphs all year are going to be in this menu. You make sure that plot is turned on, and then this one here on the very end, that last one that looks like a line, is our normal probability plot. And so here you do have to tell your calculator where the data is, and then you also see this new window where it says data axis. You're just going to keep it on X. That means that it's going to keep those original X values in list 1 on the X axis. And then you just pick how you want the points to show up. Hit zoom 9 or zoom stat to see the resulting normal probability plot. Just note that this horizontal axis does show up because these are your positive z's and these are your negative z's. So that's why you see the horizontal axis on your graph. So we learned a lot in section 2.2 that's going to kind of carry us through quite a bit of the school year. We learned about normal curves in general. So again, know your notation, capital N for normal distribution. The two numbers inside are mu and sigma. We learned about the empirical rule. This is really just an estimate. So unless you're specifically asked to use the empirical rule from here on out, you're going to be more precise. You will calculate a z-score and then use the table or the calculator like we saw the other day. So a standard normal distribution standardizes everything to put it at a center of 0 with a standard deviation of 1, and that's what you use z-scores with. Once you have standardized, you can use table A to find the area under the curve. Or if you have the percentile, you can work backwards with table A to find the corresponding z-score. We also can use on the calculator the normal CDF function and the inverse norm function. And then today we talked about assessing for normality, because remember, all of the stuff that we learned about in section 2.2 only works if it's reasonable to assume that the population is approximately normal. So to assess for normality, we can plot the data and look for something that's roughly symmetric and bell-shaped. We can use the empirical rule, so counting up how many observations are within 1, 2, and 3 standard deviations of the mean. And then we can also make that normal probability plot. You will not ever be making normal probability plots by hand. That's always something that either would be provided to you or come from computer software or your calculator. So for your assignment tonight, you guys have some book problems and the Chapter 2 AP question, but please make sure you're only doing parts A and B. We have not learned about how to address the rest of that question at this point.